Hey folks, so in this video I want to talk about different ways to traverse a binary tree. So here's our problem, right? This is the thing we're going to try to solve here, right? And this is basically going to be a common problem, if you would. That is the problem, right, of visiting all the nodes in a tree. So a tree, right, we already talked about them, right? There's this idea of how a root goes to children, to children, to children, to children, right, all the way down to leaves at the very bottom. Sometimes, right, we might want to do something like print out all the elements in that tree. So what can we do, right? We need basically some specific mechanism to explore the tree. The problem, right, is that, unlike something like a linked list, right, which is linear, we have, branches, right? I have left, I have right. How do I go, right? If I want to be able to be sure that I've seen every node in a tree, right, that I maybe printed out all the nodes, for example, I need to have some sort of algorithm to do that. So we're going to be introducing 3 different algorithms for doing that, right? For looking at a tree, basically visiting every single different node that's in that tree. Note that in your previous classes, you probably didn't have discussions quite like this. So previously, right, you dealt with something like a linked list. Right? So try to recall for a second, how was it that you explored a linked list? What was it that you did? Probably did something like, node not equal, null, something like that, right? You had some sort of logic like that, right? And you did stuff inside, right? And you moved it forward, used the next variable. That was all pretty straightforward because your linked list is a linear structure. Linked list generally looks something like this. You basically have boxes where these boxes are all connected. And basically it's like, well, I only have one place to go, right? I can only go forward in this way. So I don't really have to make any choices. Now we're talking about trees. Trees have left, right children. I need to make a choice. Who do I want to visit first? Do I visit my left child first, or do I want to visit my right child first? So it's a little bit more complex. All right, so there are 3 main algorithms for doing this, right? For traversing a tree. The first is called pre-order. Then the second one is in order. Last one is post-order. Basically, these are little algorithms that tell us how do we navigate through a tree if we want to print out or visit everything in it. So looking at pre-order. Pre-order basically says, and actually, let me draw a tree really quick so we can have something to kind of talk about on the side here. So these are all different orderings. You can imagine you have a tree like this. Very, very simple tree. So I have A, B, C. Pre-order basically says, you want to view this tree? Do it by visiting the root node, right, doing something with it, and then going to the left side, doing a pre-order traversal, and then going to the right side and doing a pre-order traversal. Okay? So if I were to visit these nodes in a pre-order, what it would look like is, I'm going to go and visit A, then B, then C. Because look at, we have this algorithm here, and this algorithm says, hey, start by visiting the root, and initially, right, this is the root, A, we're going to visit that. Then do my pre-order search on this side, and then a pre-order search on this side, right? This is left, this is right. And then, right, yeah, if I have some recursion there, right, going back to the previous video, this idea of we're going to be writing a lot of recursive functions, or a lot of recursive methods. I basically repeat the same process. So it's like, over here on the left side, right, I try to do this pre-order. First thing is, visit the root. The new root is B, so I, visit B over here. But I have no children, right, so I stop there. Nothing else to do. Then I kind of back up, right, A was still being, pre-order traversed. So it's like, well, I'm done with the left side, I got to go to the right side now, print out that first node in there, right, that C. Give it over here, and then I'm kind of done, right? No left or right children to go display afterwards either. So yeah. Now these kind of different algorithms here are they're basically all the same. Okay, so here, right, kind of with the magic, if you would, right, lies in the fact that we have our visit root as the first thing in there, right? So the very first thing I do is go and visit everything that's in there. So I looked at A, right? That was the very first thing I did. Then, right, our second one is an in-order traversal, right? So in-order basically says you're going to look at your element, right, after you're done with the other side, right? So you do left side, then visit the current element, then the right side. Post-order, right, says it at the very end. All right, so how does that look, right? So in order, basically, right, it's like you imagine I start A, right, the root, then it's like, well, I got a pre-order on the left. Actually, this should say in order over here. And this should also say, let's just say post-order over here. Post. And all right, so yeah, we go basically to the left side first. Left side is B. B has no children, right? Nothing to do, just display it. Then we jump back up, do A, then do basically go down the right hand side, right? Where it's like we need to do this thing over here. We go to C, and we'll do a more kind of complicated example for one of these on the next slide. So yeah. So this is basically, again, another ordering, right, in terms of in order. So this is, the answer here is, for this little example, is BAC versus here was ABC. Last one there, right, is post order. Post order is basically just saying, right, you print or look at that node last. So it's like, well, I go left first, that leaves me with a B. Then I go right, gives me C, and then I go, finally to that root node, that A. So BCA is the answer there. All right, so these are 3 different ways basically to traverse a tree, right? So notice that I drew a tree with ABC, in it, and then over here, right, it's like I'm writing down ABC, right? So it's like I'm visiting these different things. All the algorithms are going to visit all the nodes, right? That's for sure, we need to have that. But then notice what varies is the order, right? ABC versus BAC versus C versus BCA. Okay, all those things kind of are different orderings. All right, so let's spend another minute and just do this in a little bit more detail. So now I have basically a more complicated example. So this is a pre-order traversal for a full tree, right, that has 5 nodes in it. So I have the algorithm again. So I'm going to show you guys actually kind of 2 ways to do this. So in general, right, what happens somehow, right, is this idea of, well, I can kind of imagine, right, is I'm calling functions to explore this thing. Right, so it's like initially, right, I may call pre-order on 8. This is like the first thing that I do. Right, and then I call pre-order on 8. I visit the root, right? Root, that's basically the code of me saying I want to print it out, right? Or do something with it. So 8. All right. And then what happens, right, is I have to kind of follow my algorithm here, and my algorithm says I do another call. I do a pre-order call on the left side. And I'll probably, let me just write pre. That'll be a little bit easier. Pre of 5. Pre of 5, well, first thing in that call, visit the root. Equivalent of printing out 7. Let's see. Then I gotta go right and basically so I start with calling this algorithm on 8. Then I go to calling this algorithm on 5, and then the next step is basically to call the algorithm again, right? Because that's what the pseudocode says. The pseudocode says that after you print out that root, which first was 8, then was 5, do that left pre-order, right? Recursive call on the next thing. So we do another call, right? We do a pre-order on 2. 2, right? We visit the root, get back our 2. And then, right, we are basically done, right? We don't have anything under that 2, right? There's no left or right children, so I'm done. And so what's going to happen, right, is I basically kind of unwind a little bit, right? I don't need to make any other, indents here. All of a sudden, 2 is going to pass control back to its caller, which is pre of 5. So I have pre of 5. Pre of 5, right, was, it printed out already its root, which is that 5, right? It did the call left, gave us that 2. Now I need to do the call to its right. Its call to its right, it's going to be basically a pre of 7. I notice I'm putting the indent as the same for that pre-order call to 2 and the pre-order call for 7. Basically because they're going to have, they're going to be the same because they're coming from that call to 5. Okay, they're going to be the same. So let me go and update what I was drawing on the top, which is my printed order. And notice I've actually made a little bit of a typo, so I'll correct this. So this actually here should be a 5, right? That was kind of the second thing I saw. Then a 2, then a 7. There you go. All right, so look at the 7, right? 7 basically has no children, so it's done. I can kind of go back to this thing here. But that 5, right, the call to 5 is done as well. So it basically jumps back up to its parent. Its parent realizes that, hey, I've done with the left side, that means I need to go explore my right side. So then it does a pre of 10. Pre of 10 displays 10 over here. All right. And in this case, right, we have, actually maybe I'll remove these arrows for a little bit. We can basically see, right, there's that outer call, right, to pre of 8, right, call pre of 5 and pre of 10, right, the call of pre of 5, call pre of 2 and pre of 7. And so then, right, it's like 10, right, 10 has no children, it's done, right, we print it out, we're good to go. Goes back up into pre-order of 8, pre-order of 8, called on the left, called on the right, it's done, okay? So in the end, right, we get this as our ordering. All right, so that's what we have, right, for our pre-order. The other way to do this, which is maybe simpler, is to do the following. All right, so we trace this by hand, right? This is basically me tracing all the recursive function calls. The other way to do this is the following. Start at your root and trace along the side of your tree. And then basically write down the nodes from that list. So you start at 8, go to 5, go to 2, go to 7, go to 10. Okay, you can also do that. And yes, I know that this is a lot less work than the other way. But the other way is just something you should know anyways. Don't get lazy. If you're bored, you can try to convince yourself that this is correct, right? So basically the idea is start at the root node, at the top of the root node, and then traverse counterclockwise. And then basically as you touch nodes, those should go on your pre-order. And if you want to do a post order, basically you go clockwise instead of counterclockwise. For in order, I don't have any tricks, but maybe you can come up with something. All right, so hopefully you have a good idea right now, basically, of how tree traversals can be performed.